The ocean is salty primarily due to a combination of geological and hydrological processes. Here's why the ocean is salty. 1. Dissolved salts. Over billions of years, rainwater has flowed over the Earth's surface, dissolving minerals and salts from rocks and soil. This water, rich in dissolved salts, eventually finds its way into rivers and streams. 2. River runoff. Rivers and streams carry this salty water, along with sediment and organic matter, into the oceans. As these water bodies flow towards the sea, they pick up more dissolved salts along the way. 3. Undersea volcanic activity. The Earth's crust is riddled with undersea volcanic vents and fissures. These geological features release minerals and gases, including dissolved salts, into the ocean water. 4. Hydrothermal vents. Deep-sea hydrothermal vents, located along mid-ocean ridges, spew superheated water loaded with minerals and salts into the ocean. These vents contribute to the overall saltiness of the ocean. 5. Evaporation and precipitation. Water in the ocean's surface layer is constantly evaporating due to solar heating. When water evaporates, it leaves behind the salts and minerals, causing the remaining seawater to become salter. When this water condenses and falls as precipitation, it is relatively fresh water. 6. Sea ice formation. In polar regions, sea ice forms from seawater. During this process, the ice crystals that form expel much of the salt, making the remaining seawater even salter. 7. Limited outflow. Unlike rivers and lakes, the ocean has limited outflow. Most of the water that enters the ocean tends to stay there for extended periods, allowing the salts to accumulate over geological timescales. 8. Long geological history. The ocean's saltiness has accumulated over millions of years, resulting in a high concentration of dissolved salts in seawater. This history of salt accumulation contributes to the ocean's current salinity. Salinity variation. While the ocean is, on average, about 3.5% salt by weight, its salinity varies around the world. Some regions, like the North Atlantic, are salter than others due to differences in factors like evaporation rates, precipitation, and freshwater inputs from rivers. Salt types. The primary salts that make up the ocean's salinity are sodium chloride, table salt, magnesium sulfate, calcium sulfate, and potassium. Sodium chloride is the most abundant, accounting for approximately 85% of the total salt content. Ocean circulation. Ocean currents and circulation patterns also play a role in distributing and maintaining salinity levels. Warm surface currents can become salter through evaporation, while cold currents from polar regions can introduce fresher water with lower salinity. Biotic influence. Marine organisms, especially microorganisms like phytoplankton and zooplankton, can influence the ocean's salinity. These organisms take up and release dissolved salts as part of their life processes. Human impact. Human activities, such as runoff from agriculture and urban areas, can introduce additional salts and pollutants into the ocean, affecting its salinity levels and water quality. Salinity variations at different depths. Salinity levels can vary at different depths within the ocean. Surface waters tend to be salter due to evaporation, while deeper waters may have lower salinity due to factors like freshwater inputs from underwater springs or ice melt. Salt pans and salt flats. In some coastal regions, salt pans and salt flats form when seawater evaporates, leaving behind concentrated salt deposits. These areas are often harvested for commercial salt production. Geological sequestration. Over geological time, some salts and minerals are removed from seawater and sequestered in sediment layers on the ocean floor. This process is part of the long-term geological cycling of salts. Understanding ocean salinity. Studying ocean salinity is vital for understanding and monitoring changes in the Earth's climate and ocean circulation patterns. It provides valuable insights into how the ocean interacts with the atmosphere and influences global climate systems. Geological history. The saltiness of the ocean is a testament to Earth's long geological history. Over billions of years, the accumulation of salts has played a role in shaping the composition of seawater and the planet's geology. In summary, the ocean is salty due to the gradual accumulation of dissolved salts from various sources, including river runoff, volcanic activity, hydrothermal vents, and evaporation/precipitation processes. This natural salt content is crucial for the ocean's chemistry and its ability to support marine life and regulate the Earth's climate.